Have you ever wondered what invisible forces might be lurking above our heads in the vastness of space? There's a mysterious world up there, largely unseen but deeply influential. One such hidden marvel is the Van Allen radiation belt. Imagine it as a giant donut of high-energy particles wrapped around Earth, not one but two rings of electrified gas or plasma held in place by our planet's magnetic field. These invisible rings, caught between the Earth and the cosmos, are teeming with charged particles. These particles, primarily electrons and protons, are trapped by the Earth's magnetic field, creating a dynamic and lively radiation environment. However, this isn't some monstrous cosmic beast waiting to gobble up unsuspecting astronauts. On the contrary, it's an integral part of our planet's magnetic ecosystem, protecting us from the harsh solar winds. This mysterious belt, discovered in 1958, has been a subject of much curiosity and study ever since. The Van Allen radiation belt, a phenomenon unknown until the dawn of the space age. This mysterious feature of our planet, a pair of enormous belts of radiation, was discovered in 1958 by a brilliant scientist named James Van Allen. Van Allen and his team made this groundbreaking discovery using data gathered from the Explorer 1 and Explorer 3 satellites. These early satellites, small by today's standards, were outfitted with Geiger counters to detect cosmic rays. To their surprise, the counters recorded not only cosmic rays, but something else entirely: a region of intense radiation surrounding our planet. What they had stumbled upon were two donut-shaped belts of charged particles trapped by Earth's magnetic field. These belts, now known as the Van Allen radiation belts, are a testament to the hidden wonders that lie beyond our atmosphere. Without the advent of space exploration, this fascinating feature of our planet might have remained hidden. With discovery comes myths, and the Van Allen radiation belt is no exception. When we talk about the Van Allen radiation belt, it's crucial to look beyond the misconceptions that often cloud our understanding. One common myth is that this belt is an impenetrable barrier. However, that's far from the truth. The Van Allen radiation belt is not a wall that blocks the path of spacecraft. Instead, it's a region of charged particles, held in place by Earth's magnetic field. Another misunderstanding is the idea that the Van Allen radiation belt fries all electronics that pass through. While it's true that the radiation belt presents challenges to spacecraft, it doesn't mean that all electronics are doomed to fail. With the right shielding and protective measures, spacecraft can and do navigate through this region safely. It's also worth noting that the belt's intensity varies. It's not a constant, unchanging field of radiation. Factors such as solar activity can cause fluctuations in the belt's intensity, making it a dynamic and fascinating phenomenon. And lastly, let's dispel the myth that the Van Allen radiation belt is harmful to astronauts. Yes, the radiation is more intense than what we experience on Earth, but with protective measures and careful mission planning, astronauts can and have traveled through this region without harm. Understanding the true nature of the Van Allen radiation belt allows us to better navigate the challenges it presents. The Van Allen radiation belt, while not a concrete wall, still presents a significant challenge for space travel. Imagine it as an invisible shield around our planet, a shield that's filled with high-energy particles. Now, these particles can be quite a nuisance for spacecraft and astronauts. You see, the radiation within the belt can damage the electronic systems of spacecraft. It's like an unexpected hailstorm that can wreak havoc on an unprepared traveler. And for our human astronauts, the radiation exposure can have serious health implications, increasing the risk of conditions like cancer. But fear not, we've got some tricks up our sleeves. Engineers and scientists mitigate these effects by designing spacecraft to be radiation hardened. This means they use materials and designs that can withstand the belt's radiation. As for our astronauts, mission planning involves timing the travel to avoid the peak radiation times, and the spacecraft's course is charted to spend as little time as possible within the belt. It's a delicate dance, a battle of wits against the forces of nature, but it's a dance we must learn, a battle we must fight for the sake of exploration, for the sake of knowledge. The Van Allen radiation belt, a fascinating and complex feature of our planet, continues to challenge and inspire us as we reach for the stars.